Welcome back. So here is another problem testing on application of Cauchy's integral theorem or integral formula. So the first step to solve the problem is to find the poles of the integrand. So the poles are easily obtained by equating the denominator of the rational function of the integrand to 0 and then solving. So solution. First, we find the poles, which are obtained by taking the denominator and equating to 0. So z squared plus z equate to 0, which is the same thing as saying z into z plus 1 equals to 0. This implies z equals to 0 and z equals to 1, negative 1, are simple poles. Simple poles because this is raised to power 1, this also raised to power 1. For the integrand f of z given by 2z plus 1 over z squared plus z. That's step 1. And then step 2 is now to sketch the specified circle or specified curve to see whether all the poles lies within or outside the circle. And this means circle center 0, radius a half. So if we do the sketch, so this is the imaginary axis, this is the real axis. So this is 0. So this is I, this negative I, this is 1, negative 1, this 1. Then this being our center by definition of the circle. So this is positive 0.5 I, negative 0.5 I, 0.5, negative 0.5. If you call this one Z1, you call this one Z2, then if you locate them, this way you have Z1, and then Z2 is negative 1. So you see this one is outside. So we only concentrate on the pole which is within the circle C. So only Z1 equals to 0 is within the circle Z equals to a half. So by Cauchy integral formula, so i.e. integral along C, f of z, z minus a dz gives us 2 pi I, f of a, we evaluate the integral for z equals to 0. Because actually the other value will give other value, its integral automatically, small circle done around z2 is going to be 0. So only concentrate to the poles which are within the circle C. So integral along C, and then our function was 2z plus 1 over z squared plus z dz can be written as integral 2z plus 1. Now this is the same as z into z plus 1 dz. So our interest, because the only pole which is within the circle specified is z equals to 0. So we expect this denominator to only have a z value. So we do that one by dividing each numerator and denominator by z plus 1. And that will give us integral of 2z plus 1 over z plus 1 divided by z dz. Remember, when you simplify this one, you still get back the original equation. So where our f of z is now 2z plus 1 over z plus 1, a is 0. So, which means that the integral of 2z plus 1 over z squared plus z dz will be 2 pi I. F of a, our a is 0, which will be 2 pi I times. So this is the f of z. So when you say f of 0, you put where the z by 0. So 2 by 0 plus 1, 0 plus 1. So which will be 2 pi I times, this will be 0 plus 1 is 1, this will be 1. So the answer will just be 2 pi I. So that is the answer to that particular problem. Assuming that the radius of the circle was, say, 3, which means then all the two poles, 0 and -1, will be within the circle. Then once you evaluate this value for z equals to 0, you do the same for z equals to 1, equals to -1, and then add the two solutions. Thank you.